good. Let's look at part B of our example, right? So we already figured out part A in our previous video. Now they're telling us also that the force of friction is 45 newtons. I didn't write it down before. I'm writing it down now. Okay, and they're asking now for the acceleration. I must say that part B is a more realistic problem since friction is always present. Okay, let's start collecting our data, what we have so far. So once again, we know that the mass of our skier is, with the equipment, is 60 kilograms. We also now know that the force of friction is 45 newtons, and we also learned from the previous example what our force applied is. The applied force is 200, let me move this up a little more, 248.5. Once again, remember that this applied force in our previous example turned out to be the net force. Why? Because we were asked to ignore the force of friction. Okay, and of course we are looking for the acceleration here. Let me just put it down here with a question mark. Okay, so now we are still going to use that formula, which is force equals to mass times acceleration, and might as well just start writing it down. So before we find what the acceleration is, and example B, it will be different, of course, because now we're involving friction. Well, let's remind ourselves of this, right? The net force, it's equal to the applied force minus the force of friction with a small f. Force of friction, small f. Okay, good. So let's start looking at this. So first, we need to find the net force so that later on we can use our formula, this formula. Well, I'm going to end up writing it again anyways, but I just want to show you. Right. We're going to find our net force first, and once we have that, we can figure out what the acceleration is. Okay, so now let's figure out the net force, step 1. So our net force will be, well, our force applied was 248.5 newtons minus the force of friction, which is given to us, it's 45 newtons. Okay, so you put it in, you subtract it, and you get 203.5 newtons when you subtract these two. Now we know what the net force is, and now we can use this formula now. F net equals m times a. So that we can figure out what the acceleration is. So let's do that right now. So I'll continue here with green. I hope you're not colorblind, but in any case, right, mass times acceleration. Okay, so we write down 203.5 newtons, which is our net force, 60 kilograms, which is the mass of the skier, times the acceleration. So we solve for the acceleration, and acceleration is going to be equal to this 203.5 newtons divided by 60 kilograms. Our answer is 3.39 meters per second square. So that is, considering friction, the acceleration of the skier down the hill is going to be 3.39 meters per second square. Okay, so the main difference really between examples A and B is just in example B we're considering the friction, and so it's something that, you know, it's something that we need to consider for our example. So we subtract it from the applied force, right? And of course you may see examples in which they ask you what the acceleration is considering the friction. So we would basically solve part A like this. Part A, when we get the applied force, once we have the applied force, we simply go ahead and we start doing part B to figure out what the net force is and the proper acceleration with friction. Any questions, just let me know.